Ma'am, you are on mute.
Okay, am I audible now?
Yes, ma'am.
Right. Now people are coming. When we waited for them, they didn't turn up, and now people are coming in between. So we're going to start with a new chapter today, Association Rule Mining. This is chapter 6 of your book. First of all, let us see what is an association rule. Okay? An association rule, as its name suggests, depicts it is a rule that depicts an association between two or more items that we have in our data set. Okay. Now, what kind of association? Generally, this association is formed due to the fact that these items co-occur together in a set of transactions. Suppose this was my market basket data set. I had introduced you to the market basket data set earlier. Do you remember? So, a market basket data set basically represents a set of transactions. Each transaction represents a basket of a particular client in a market space. So, basically denotes the items that he is buying from the market, right? The items that he is interested in buying from the market. So these are, let's say, some actual transactions. This kind of a database is also known as a transactional database. If you remember, we had also seen that this representation that you see on the screen right now is one of the representations of the market basket database, in which the first column is the transaction ID. As with any identification, a transaction ID is a unique number generated for each transaction when a transaction takes place. And the other column is the set of items that have been bought in that particular transaction. Occasionally, along with these two columns, there is another column that stores the timestamp of the transaction as well, right? So, date and time, which involves the date and time, right? But for our purpose at the moment, let us look at this particular market basket data set. So, the kind of rules that you see here are called association rules. What the first rule means is that whenever diapers are being sold, beer will also be sold. Okay, what this means is that generally, when the diapers are sold, beer will also be sold. Do you remember the story that I told you? A very interesting story that I told you to emphasize upon the novelty of patterns that are delivered by a data mining technique. So initially, what happened? There were these laborers who were working near a small mart in US, and people they shopped for their needs, uh, generally on a Friday night from this mart. So when the laborers went to the mart on Friday night, generally, you know, they would buy uh, a bottle of beer or two so that they could enjoy their weekend. Now, it just happened incidentally that Very close to the beer was a rack of diapers, incidentally, by chance. Right? That reminded them immediately when they bought beer, it reminded them that as soon as they get home with a bottle of beer, they were going to be nagged by their wives, you know. Why? Because, uh, of course, the wife had to take care of the house entire day and the kids, pestering around her the entire day, and the men folk are out of the house generally, and on the weekend they can have a complete weekend to themselves, but the women folk don't have, right? They still are required to do the same household chores and look after the kids and additionally after the husbands, right? So, in order to do away with this nagging, to avoid this nagging, they used to buy the first thing that came to their mind, that would show their wife that they are, they care about the household as well, or the kids. So they would pick up a packet of diapers and land home, right? So this store, people started, they just by the way, they chose this store for data mining. So the algorithms were applied on the transactions for a past couple of months and so. And this rule appeared. Okay, so one of the rules that appeared was diaper implies beer. So, of course, the people were very astonished, and they actually said that it is all a bullshit. Data mining is all a bullshit. It gives wrong, inconsistent patterns. This cannot be true. They said this cannot be true. But then later they realized, when they analyzed the patterns, they realized that really the stack of diapers was placed adjacent to the stack of beer bottles. Okay, so uh, which led to this discovery that uh, uh, this rule was not wrong. In fact, this was something that nobody could have thought of. You know, bread and butter selling together, bread and jam selling together. This is common knowledge. Uh, I should say domain knowledge that comes from the experience, right? From it'll generally come to anybody who sits on a shop for, let's say, a week or two, right? And then there are many other commonly found patterns which a shopkeeper gets aware of over time, that these are the things that get sold, together, right? But this kind of pattern nobody could have predicted. And please say, this was such a uh, breakthrough. This was considered such a breakthrough because it led to the concepts of your shelf management today. So, how do you lay out your store so that the client, when he comes to your store and is buying one thing, is tempted to buy the other? Okay. So, as I commonly say, this can be done by either placing two things in very close proximity to each other, or if you have a circular shop where there is a single entry single exit kind of a setup, then you could place the very commonly together selling items, one at the entry and other at the rear, right? So when the person goes out looking for, let's say he's buying bread and he wants to look for eggs or butter, so he goes around the store looking for butter, and he inadvertently picks up let's say, other items that he may not have at the top of his list to buy, right? So the similar thing you see happens when we go out to buy groceries. So, again, this is an example that I give my students generally, that if sometime, our kids would go along with us, and we went on a monthly grocery shopping trip to the nearby mall. So you won't believe the entire 2 hours, 2.5 hours, in which we would shop for the things, we could keep the kids from picking up things that they wanted, for instance, chocolates and all. But at the end, when you come to the billing counter, they've placed things there where you have no escape. You know, the kids are generally tired by that time, and they would, uh, you know, really eat you out if you don't buy them those knickknacks from there, right? So this is all because of the concepts of shelf management, which are in practice today. Again, because of they are based on very sound principles founded by data mining. Okay, so an association rule is a pattern of the form of a rule which depicts the association. What kind of association? The association of a co occurrence of the two items on both sides of the rule, right? Now, I would like to generalize this concept. So, up till now, I'm saying we're talking about an item. However, as we are aware that there could be multiple items on both sides, so let us expand this concept of an item and start talking about something which is known as an item set. Okay, so what is an item set? An item set is a set of items. That means a collection of one or more items. So, for instance, this milk bread that you see here, I'm not letting anybody in now. Uh, the reason is that, this thing is not getting resolved. I don't know who wants to come in. There is a request, but every time I have to break from what I'm talking about, and I have to go and admit people, and that also after waiting for 3, 4 long minutes for the people to come in. Okay, so I request you all to kindly be on time next time, and also spread this message around to your friends. Right. So this milk bread that you see here is a two item set, right? That means two items taken together, right? Considered together. Eggs, pork is yet another example of a two item set. In general, when we consider k items together, it will be called a k item set. So the idea is that on both sides, that is the antecedent and the consequent of this association rule, we may have more than one item, right? So we call it a k item set on either side of the association rules. Now, let us talk about what is the support count of a item. Just give me a second, please. Very. Support count. What is a support count? So, basically, the frequency of occurrence of an item set is known as its support count. That means, in other words, how many times that particular item is occurring in my market basket data set. That means how many, or put it even more simpler, in how many transactions a particular item set is likely to appear. Okay, it is appearing. Okay, just a sec, students. Yeah, so the number of transactions, for example, that contain bread in this data set which is given to us are, for example, transaction number 1, 2, 4, and 5. So the support count for bread would be 4. Okay. Now, similarly, the support count for milk, bread, diaper would be, let us see, the transactions in which the all three items are being sold together. So, milk, bread, and diaper. So, this is transaction number. Transaction number 4 and 5, right? Two transactions here. So the support count is equal to 2, right? What is support? So this is just a variation of support count. Support count is absolute, whereas support is a fraction. It is generally taken to be the number of transactions that support this particular item set. Support this item set means that contain this item set divided by the total number of transactions. Okay, so the support of this same item set would be 2 by 5. Any problem up till now? Okay. Now, what is a frequent item set? So again, please look at the use of the word frequent. The item set which is brought very frequently, most popularly, most of the times, is called frequent item set. Any problem in this? The only problem is that most of the times, what do we mean by most of the times? What is the quantification for most of the times? Well, uh, we don't decide upon any one. Actually, we cannot decide upon any one threshold to decide whether a particular item is frequent or not. Okay, so for instance, in summers, the sale of Coke is maybe very high, right? But in January, uh, the sale of Coke would drop down drastically, right? It would be very, very small compared to the numbers that are sold for a particular uh, so, cold drink can in summers, right? So, how can we decide upon a particular number and fix it? And what happens, especially when I change the item? So, this time now, I'm not talking about Coke, but let's say I'm talking about diapers. Diapers are sold almost at the same frequency, maybe, you know, in the entire month, right? And what happens if I change the geographic location? So, in a very urban, modern, well to do neighborhood, branded clothes may be very common. But if I were to take the same uh, store in a rural setup, do you think the branded clothes would sell equally frequently there? No. Right? So there are, I've just named maybe 2 or 3 factors here, but there may be many, many factors that affect the sale of a particular item, right? It may be the time of year, it may be the popularity of an item. For example, ginger ale is not very common here, but it's very common in US. It may be the buying patterns of the people, right? If they just, if they're not well to do, they will always opt for a cheaper alternative, right? So there are many factors. So we cannot, decide for sure that this particular threshold is going to be good for item set to decide that, if it sells more than this threshold, then I can call it frequent, right? So by choice we keep it subjective. By choice we keep this threshold subjective. Subjective means that the user tells me that this threshold, if the sale of this particular item crosses itna threshold, then I would consider it, a popular item in my area. And the thresholds may be set differently for different item sets. Okay, so while an item X is sold, let's say, mm, 50 times in a day, item Y may only be sold once in 50 days. Right? So that is why it's a choice that we leave the choice of this threshold beyond which we will consider an item set to be frequent to the user. Okay. Looking at the formal definition now. So, what is a frequent item set? An item set whose support is greater than or equal to a minimum support threshold that is specified by the user. Is this clear to everybody? Is this clear, students?
Yes, ma'am.
Right, thank you. Now, does this mean, by the way, that the grass is all green? That means, should the minimum support threshold always be, subjective? I mean, is it always very advantageous to choose the thresholds as subjective measures and not, fix them? Well, that is also not always the case. The reason is that if you ask me to go and sit at a shop at a particular shop, and ask me to decide about the thresholds, uh, the results may be not very good, right? However, if the person who owns the shop, or maybe his son, maybe his daughter, who are likely to have some domain knowledge and experience, if they were to decide these thresholds, then the results would be much better, right? So, this is a trade off that we need to keep in mind, not just for the minimum support threshold, but for all subjective measures that we ask from the user. Okay, so we have to take into account that the user uh, will give us the inputs according to his domain knowledge. Right? Now, there may be an enormously high number of association rules which may be generated from even a very small database. Okay. For example, if I were to have only 6 items in my uh, database, okay, uh, this is the total number of rules that can be generated from a database that contains only 6 items. Okay, and I think we had this talk earlier. Let's pick up a small bania shop near your household. How many items do you think that bania shop would have? Let's start counting. Band-aid and Dettol and cotton and matchsticks and candles and agarbatti and bread and eggs and oh well, I think we could keep on counting by the end of the day and still will not be finished with this exercise, right? So there may be thousands and thousands of things which a very small shop also houses, right? Can you even imagine the number of association rules that will be generated if we were to consider all items and generate all association rules from them? It would be, explosive. It would be explosive. And the problem of generation of this high number of association rules would be computationally prohibitive. Okay, it would be a NP hard problem, as you say in algorithms. I think you've done a course on algorithms, right? So it would be computationally very prohibitive to even think of generating the rules which are so large in number. So what do we do? What do we do? There is another thing that I note in this context, and that is that all association rules, even if I were to generate them, may not be very interesting. Okay. For instance, in a single transaction, if there was a single transaction in a day in which two very rare items are sold together, and then they are not sold together for another 6 months, do you think the shopkeeper should, invest in that item Y whenever he invests in the item X? Should he stock up Y whenever he stocks up item X if they were sold rarely together, maybe once in 6 months? No, it doesn't make sense, right? Now, won't this be an association rule if I were to mind? It would be. This X implies Y will also be a valid association rule. It is based upon a transaction that actually did happen once, right? But it is not that interesting, right? So, would I be wrong if I said that we should look for interesting association rules rather than all association rules? Tell me. In fact, we should look for only the association rules which are strong. Which are strong means which have a very high probability of, you know, occurring, right? So, for example, which have support, uh, which have a high support. Now, if I say that this particular association rule has a high support, what does it mean? It means that the mere fact that this is stating that the milk diaper, whenever milk and diaper are bought, beer will also be bought. If I say that the support of this is 1, that means 100% of the times, whenever milk and diaper are sold, beer is also sold. So it is with this certainty that I'm saying, if I say with this certainty, then obviously this rule becomes very interesting. So obviously, greater the support, the more interesting the rule is for me. But support is not the only metric which we are going to look at. There is another even more strong metric that we use to evaluate an association rule. This is called a confidence. So, what does the confidence tell us? The confidence tells us that if this is a particular association rule X implies Y that I'm talking about, then in how many transactions that contain X, Y is also likely to occur. Do you understand the difference between the support and the confidence from the definition? Please see, in support, we were looking at, if we are talking about X implies Y, then we are looking at the number of transactions that had both X and Y from the total of the entire data set. That means divided by the entire number of transactions which are present in my transaction data set, right? However, in the second case now, in the case of confidence now, I'm looking at specifically the transactions in which X has been sold, and I'm focusing whether in those transactions Y was sold along with it or not, or how many times Y was sold along with X in those transactions. Okay. So, for example, if we talk about this association rule, let us try to find its support. What would be the support of association rule? Milk and diaper implies beer, given this transaction data set. So I'll count the number of transactions which have these three things selling together, which is milk, diaper, beer 1, and milk, diaper, beer 2, right? So 3 and 4, right? Transaction number 3 and 4, which makes it two transactions, right? 2 out of 5, okay, which gives me 0.4. Now, when I go out to compute the confidence, I divide the same number with the number of transactions in which milk and diaper have been sold. Okay? So I'm trying to see what is the percentage that if milk and diaper is being sold, beer will also be sold, right? So when I divide this is obviously 2, milk and diaper is being sold in, let's see, how many transactions? You tell me. Transaction number 3, 4, and 5, right? That is 3, right? So 2 by 3, which gives me a metric of 0.67, right? So this is a more stronger metric than support. Okay, this is a more stronger metric than support. We look for the rules with high support and high confidence. Okay, so the rules which have high support and high confidence, both of them in ascending quantities are better, right? Now, so we narrow down our goal of generating the association rules now to the following set of constraints. That is, we will generate the association rules only if its particular support, if the support of that association rule is greater than or equal to the support, minimum support provided by the user. And similarly, the association rule has a confidence which is greater than a minimum confidence threshold that is provided by the user. Okay. So how would this strategy work? How would this strategy work? Well, the very brute force, that is the very primary technique to implement this would be that I list all possible association rules. Okay. And then I compute the support and confidence for each of them, right? And then match the support and confidence with the uh, minimum support and minimum confidence given by the user, and evaluate each rule whether it is interesting or not, right? Well, all good in theory, right? The algorithm seems good in theory, but remember the number of rules that we talked about, even for a small number of item sets, six. In fact, there is this formula 3 raised to the power of d, where d is the number of items in the data set, minus 2 raised to the power of d plus 1 plus 1. Now, this formula you need to remember. Generally, its derivation doesn't come, but sometimes you're given if d is equal to 5 or d is equal to 10, then how many association rules uh, can be generated using this? So, you need to remember this formula. So, from this formula itself, you can see that this is a or this is a very big, this is going to be an explosive number, right? So obviously this kind of technique is not going to work for the generation of association rules. Okay, so I, as an assignment, I want you to think about how you would then deal with this problem if you were to write this algorithm for generating the association rules given all these constraints that we've talked about. How would you do it? Okay, to make it feasible to computationally. Okay, so this is your moment of research, by the way. Okay, you look at, you obviously you have all the resources with you, you can go to the net, you can look at your textbook, but then what you put at stake is that excitement that research brings you. Okay, maybe you'd like to test how well I am at solving a problem, and let me then after that look at the solutions proposed by the data mining community. Maybe yours is still better. Okay, so I leave you here today with this opportunity in your hand, and next time I'd like to hear what you have to say, how you would like to solve this problem. Okay, students? Next time we are going to discuss about the generation of association rules. So the exact algorithm of how the rules are generated. I'm going to be sharing your attendance link. Please mark your attendance before you go.